Last time we looked at solving equations that look like this, given one of the zeros, and you would use synthetic division to figure out your depressed equation and solve from there. Now, what happens if you don't get given a zero? Seems like it would be a little tougher, but we have a method to help us get through it. What we do is we use something called the rational root theorem. And really what the rational root theorem says this is if we put factors of the constant term over factors of the leading coefficient, we're going to get a list of all the possible rational roots for the equation. So if we try here, factors for our constant term, well in this case our constant term is -1. So if I find all the factors for -1, I'm going to get +1 or -1. So we write it like that, plus or minus 1. For our leading coefficient, here's our leading coefficient. So we've got factors of plus or minus 1, positive and -2, and positive and -4. So now what we do is we just take each of these numbers and plug them into this format. So to find the list of all possible rational roots for any equation, we take those factors of the constant, which are 1 and -1, and the factors of the leading coefficient, which are plus or minus 1, plus or minus 2, plus or minus 4, and we just make fractions out of them. 1 over 1 is 1, and we've got positive or negative because that sticks around. 1 plus or minus 1 over plus or minus 2, which gives us plus or minus 1/2. And 1 over 4 plus or minus 1/4. If I'm asking you to find all the possible rational roots, again, the possible rational roots, they may not actually be rational roots, we'd have plus or minus 1, plus or minus 1/2, and plus or minus 1/4. Now let's take this one step further. Now we're going to find any rational roots for the following equation. If the equation has at least one rational root, we're going to solve it completely. So once we have that list of roots, which in this case, since we're dealing with -2 and 2, for -2 you've got factors of plus or minus 1 and plus or minus 2. Factors of +2 are going to be the same thing, plus or minus 1 and plus or minus 2. And we're going to make them into fractions using the factors of the constant over the factors of the leading coefficient. So 1 over 1 is 1. 1 over 2 is 1/2. 2 over 1 is plus or minus 2. And the 2 over 2 becomes 1 again. So we're going to leave these as our rational root. Now, we're going to check to see if any of them work. So let's try a couple of them. Let's first try 1. If we try 1, we're going to use synthetic division. So we get 1, which is 2, -5, 6, and -2. Bring down the 2. 1 times 2 is 2. 2 plus -5, so we get -3. 1 times -3 is -3. 6 minus 3 gives us 3. 1 times 3 is 3, which leaves us with a remainder of 1, which means positive 1 doesn't work. We could try -1. -1, again 2, -5, 6, and -2. Bring down the 2. 2 times -1 is -2. -5 times -2 is -7. -1, so -1 times -7 is 7. 6 plus 7 is 13, times -1 is -13, which gives us -15. That doesn't work. So let's try 1/2, see what happens there. 1/2. We got 2, -5, 6, and -2. Bring down the 2. 2 times 1/2 is 1. -5 plus 1 is -4. Times 1/2 is -2. 6 plus -2 is 4. Times times 1/2 is 2. -2 plus 2 is 0. So we had a depressed equation of 2x squared minus 4x plus 4 equals 0. And it also means that in my final answer, 1/2 is one of my rational roots. Now, since we have a quadratic, we have a few different ways we can solve this. We can check to see if it's factorable, or we could just throw it into the quadratic formula, which is what I'm going to do. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, it's all over 2a. The negative b is also over 2a, not just the radical. So then we take each of these numbers. 2 is a, negative 4 is b, 4 is c, and we plug them in. X equals negative 4, which is positive 4, plus or minus the square root. Negative 4 squared is 16, minus 4 times 2, which is 32, all over 2 times a, which is 2, so we get 4 in the denominator. Simplify that down, we get 4 plus or minus the square root of negative 16, all over 4. Here with the negative 16, since there's a negative inside the radical, we get to turn it into an imaginary, it is an imaginary number, so we get I. And the 16, square root of 16 is 4, so we get 4 plus or minus 4i all over 4. That's a 4. 4 is simplified down, so this becomes 1 plus or minus 1i all over 1. So my other two zeros, or my other two roots, my other two zeros, whatever you want to call them, are 1 plus or minus I. And these are your three roots. One of them is rational, the other two are not, but you can still solve it because you got down to a quadratic and we can solve quadratic equations. One more example. Since this is x to the fourth, we're going to have to go through the rational roots process a couple of times first. In order to do that, let's find the rational roots possible here. So we've got negative 6 and 1, so anything's going to be over positive or negative 1, so really our rational roots are going to be any of the roots of negative 6, which are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So these are all possibles. So again, we go through and we check. So we first check 1. We got 1x to the fourth, 3x cubed, negative 1x squared, negative 9x's, negative 6. Bring down the 1. 1 times 1 is 1. 3 plus 1 is 4. Times 1 is 4. Minus 1 is 3. Times 1 is 3. Which gives us negative 6, which ends up with negative 6, which ends up with negative 12. Well, if we could end up with this negative 9, 3 situation again, but this be negative 1, we may have gotten to a 0 as a remainder, and then so we would have had a rational root. So how about we try that? Instead of 1, let's try negative 1. So negative 1 is 1, 3, negative 1, negative 9, and negative 6 for our coefficients. Bring down the 1. 1 times negative 1 is negative 1, which leaves us with 2. Negative 1 times 2 is negative 2, which gives us negative 3. Negative 1 times 3 is 3, which now leaves us with that negative 6. Negative 6 times 1 is positive 6, and that gives us 0. So our new depressed equation is x cubed, plus 2x squared minus 3x minus 6 equals 0. Which I have up here pre-written just so I have more space. And now we go through the process again. So again, leading coefficients 1, constants negative 6. So again, really it's just the factors of 6 because this is a 1. So we get plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6 as all possibilities. So then we go through and we check again. Well, we tried positive 1 earlier, that didn't work. We've just found negative 1 is 1. It could be a double root, but let's move on and try the others first and see what happens. So this time I'm going to try 2. So if we try 2, this time instead of using all this, we're now only using the depressed equation. So we've got 1x cubed, 2x squared, negative 3x's, and negative 6. Bring down the 1. 1 times 2 is 2. 2 plus 2 is 4. Times 2 is 8, which leaves us with 5. 2 times 5 is 10. Well, that's not going to give us 0. That's going to give us 4. So 2 doesn't work. Let's try negative 2. Negative 2. And again, 1, 2, negative 3, negative 6. Bring down the 1. 1 times negative 2 is negative 2, which gives us 0. Times negative 2 is 0. Minus negative 3. Negative 2 times negative 3 is positive 6, which gives us 0. So we get a depressed equation of x squared minus 3 equals 0. Now, we found that negative 2 is a root, and we found that negative 1 is a root. They're two rational roots for my original equation. We could keep going and keep checking the others, or since we now have a quadratic, we can actually just solve the quadratic. We got x squared minus 3 equals 0. There's a couple of ways we can solve this. We could use the quadratic formula. We could use completing the square. However, I'm just going to use the fact that if I take a square root of x squared, it's just going to become x, and I could solve it that way. This way I've got x squared equals 3 by adding 3 to both sides, and then I take the square root of both sides. When I take the square root of both sides, I need to remember to include a positive and a negative, because positive, whatever this number comes out to be, times itself, or negative, whatever this number comes out to be, times itself, is going to give me my original problem, because if we square, it always becomes positive. So the radical and the square eliminate each other, and we got x equals, the square root of 3 is an irrational number, and we can't simplify it any further, so we just say it's positive or negative square root of 3. So our final solutions for this equation are negative 1, negative 2, and positive or negative square root of 3. They become our 4 solutions. And yes, this can be time consuming. However, it's a way to solve equations that we've not been able to solve in the past.